That's wrong one. What the heck? Yes.
I was gonna do an announcement to say like 5 minutes, but
Why is it tripping? It's not showing up.
nothing's showing.
Hmm. It says there's one scheduled for. Oh wait, no, I see it.
Consider sound. Alright. Alright, thank you. Yeah.
Oh,
Let me. Hello, everybody. We're gonna get started in like 3 minutes, so just wait for a few more people to come in. So. Start with a minute. What? Yeah, I got you. Say that again? Okay. You can start right now. 7:05.
all right. What is up, y'all? Hello. How are y'all doing today? Good. Good. Dang, there's like 2 people that gave a thumbs up. That's kind of sad. Anyway, I'll just assume you're shy. So welcome to the first ML Monday. Glad you guys are all here. We had a pretty good turnout. So my name is Mark. I'm vice president of AIS. This guy, he's the important guy. His name is Zain, one of our AI 51 people. So basically, over the course of the semester, we'll do a few different ML Mondays, and we'll have like different people presenting every time. First one is Tesla vehicles and other stuff along those lines. But anyway, I'll let them get to it. Stick around to the end for the little member code thing. Yeah, cool.
All right, hello everyone. Welcome to the first workshop of the semester. So today we are going to be talking about artificial intelligence in vehicles. So we are going to be talking about some of the general concepts and applications of AI in vehicles, as well as some basic machine learning concepts as well. So yeah, let us get started. All right, so I wanted to start this presentation off with a question, and it is, why is AI being incorporated into vehicles in the first place, right? And this may seem like a pretty dumb question, but it is a question worth asking, right? Because at the end of the day, if you don't know why you're incorporating a certain technology or AI, why are you incorporating it, right? So I wanted to get a few answers from some of y'all. Um, feel free to raise your hand if you have any ideas. Yeah, definitely more efficient traveling. Yeah, self-driving, definitely. Yeah, definitely auto detection of any obstacles. You gotta ensure safety as well, right? So I wanted to show you this okay. Thank God. All right. So I wanted to show you guys this promotional video from this company called Waymo. Who here has heard of this company called Waymo? Okay, so decent bit of y'all. So basically, what they are is they are a company that's been doing a lot of great work within the field of self-driving vehicles, fully autonomous vehicles, and their business model works very similar to companies like Lyft or Uber, where the idea is that you have a mobile app and you can just request a ride, and instead of a human driver, you'll have a fully autonomous self-driving vehicle, right? And from what I know, they are only available in San Francisco and Los Angeles, I believe. But I think next year they're gonna start having their services open in Austin. So if you live in Austin, you might be able to use some of these. So let me play this video for y'all. So yeah, pretty cool. Did any of you guys learn anything new from that video? Just curious. Yeah, that's kind of what I thought. I mean, you don't really need steering wheel if it's fully autonomous, but yeah, I think it's really just there if, just in case of an emergency, someone, a human being, can steer the vehicle in the right direction, I guess. But I don't really know the true reason behind that. But yeah, that's a good question. Anything else anyone want to share? All right, so let me move on. Oh, my bad. All right, so just to sort of answer that question you were talking about earlier. So what are the actual applications of AI in vehicles? Well, first of all, we just saw autonomous driving, being able to detect objects around you or around your vehicle and make driving decisions based on the data and your environment as well. So you can sort of see that this is kind of like an input-output relationship, right? So the input is your environment, and your output is your navigation system making decisions, right? And next up, we have driver assistance systems. So this is something you can see more commonly in today's vehicles, right? I'm pretty sure a lot of Tesla vehicles have these driver assistance systems as well already built in. But these include things like automatic braking. If you see an object right in front of you, it just automatically brakes, pretty straightforward. Lane keeping assist. So this basically just makes sure that if your vehicle kind of drifts to the side, it just tries to make sure it straightens out into that lane. And then we also have adaptive cruise control, which is basically making sure that your vehicle maintains a safe distance from the vehicles around you as well, right? And that kind of introduces a new element of distance, right? It's not about just being able to see objects. You want to be able to know how many meters are away from your vehicle, and that can definitely complicate things, right? But yeah, some pretty cool stuff with driver assistance systems. And lastly, we also have the voice recognition systems as part of the in-vehicle experience. This may not be as relevant as these other systems, but it is still definitely worth to mention since they do incorporate a lot of deep learning models for their voice recognition systems as well. So definitely worth mentioning as well. All right. So the next question I wanted to ask you guys is, we covered the why. How is AI being incorporated into vehicle? Now I'm just realizing that, but being twice. But does anyone have any ideas on how this is even possible in the first place? Dedicated operating systems, yeah, definitely. Computer vision, yeah, that's a big part of it, yeah. You said reinforcement learning? Yeah, definitely. Reinforcement learning plays a big part of this as well. And the other ideas, yeah, so you guys are pretty much on the spot. But let me, okay, let me play this video from NVIDIA. I'm sure you guys know what NVIDIA is, obviously, but this they cover more of the technical side of how computer vision works in the uh, concept of self-driving vehicles. So I'm going to show you all this. Should be a pretty quick video. yeah, pretty cool stuff as well. I'm gonna ask all this again. What did you guys learn from this video? If you guys learned anything at all? All right. I'm just gonna move on. So to kind of summarize this video, the main idea you want to be able to get from this video is just that whenever we're incorporating computer vision, we want to think of it as being able to segment the objects that it sees in a way. So you can sort of see that, like people have different color, and like you see a sort of like ID within each of those objects, right? And the idea is just being able to detect those different objects and ID them or put them within a certain category or class in order to make driving decisions, right? So that's just kind of the general idea that I wanted to take from this. So let's move on. Okay. Okay. So some of the applications of AI in vehicles, or like how this is even possible, is through, like some of you said, deep learning. So this is usually done using convolutional neural networks, and that's something we'll definitely go over more in detail in later slides. We also have obviously computer vision, and we kind of saw in the last video, we incorporated semantic segmentation, which is just being able to separate the objects within your environment by an ID or class. And once again, this helps us make driving decisions and decisions to ensure safety while you are in your vehicle. And then you also have reinforcement learning. So I think in the first video that we looked at, they mentioned being able to simulate environments that may not be commonly seen whenever you're in traffic, right? So this is definitely really important because you're not able to um, get all those real world environments while you're in, practice and testing, right? So sometimes being able to simulate them and incorporate concepts of reinforcement learning can definitely help with that, right? So to kind of go over what a convolutional neural network is, what it is, it is basically a type of deep learning model designed for processing grid-like data. And the idea behind this is that it uses layers of filtering to learn and detect patterns within those grid-like data, right? And I want to ask y'all guys, whenever I say grid-like data, what does that mean? Yeah, you're definitely right. But like, what type of like file, for example, like what is it like? Well, I was mainly looking for images, right? That's kind of what I need, right? Because if you really think about it, right, an image is really just a bunch of pixels, right? Like, for example, you have an image that's 256 by 256, right? You can sort of think of that as a 256 by 256 grid, right? And the cool thing about those images is that we can actually interpret each of those, I guess, pixels as a number, right? And the fact that we can do that allows computers to be able to interpret that data and also incorporate that data within convolutional neural networks or any type of machine learning model, right? So that's kind of what allows us to perform these different features such as object detection, semantic segmentation. It's through just this idea of being able to um, interpret these images as numbers, right? And obviously, this is used widely in image recognition tasks. Typically, in a driving environment, you're going to be processing, hundreds of frames per second, right? So you're basically kind of performing this operation or evaluating each of those frames each second, right? Just so many frames each second. So that can definitely be computationally expensive as well. So So to kind of go over what a convolutional neural network is or what its architecture is, you sort of have, first of all, this input-output structure. We have the image itself, or the frame that it's looking at currently, and then you have the output, which is what we are currently evaluating, right? And the idea behind this is that we basically train this convolutional network to give us the outputs we want, right? So in the beginning, you're probably going to get a bunch of random outputs whenever you train your model. But as you train your model with data that already has inputs and outputs already labeled, that's how you can get to a trained convolutional neural network that you can use to evaluate images and perform tasks like image recognition, right? So just to go over this, first we have an input image, and like I said, you can sort of see how it kind of retains that grid-like structure. You have a 3x3 image that has a decimal value incorporated within each of these squares right here. And the idea is that you use this input image, you input that into this convolutional neural network, and the first thing it does is that it splits this image into features, right? And that's what this convolutional layer does. And I'm going to try to explain this more in the next slide, how it splits these features up. But the idea is that it takes some of those like defining edges or features of that image and splits them up. And after you split these up into different features, then you move them to this thing called a pooling layer. And what this does is that it basically reduces the size of these features and makes sure that it is less computationally expensive. That's kind of the idea why we're shrinking these. And we also pool them in a way where we are not sacrificing performance of our training as well. And then after that, we flatten our layer. So this basically just moves all of these high dimensional features into a zero-dimensional output. That's kind of what this fully connected layer does. It just, I guess, squishes all of those features into an output that we can actually interpret. And usually this output will be some sort of numerical value. And that numerical value would basically tell us, what the image is or what the label is of our input. So to kind of go over how it's able to split our image into features. So you kind of see that we have this image of this car right here. And you see here we have a low-level feature, mid-level feature, high-level feature. And the idea behind it is that we have multiple layers of features, right? You're typically not going to have just one feature layer or one convolutional layer. You're typically going to have like 4 or 5 in one neural network, right? So you can kind of see how this works, right? So you have like these different defining features that you can see within our image. And it might be pretty difficult to see like right here, but these are all part of the image. And we basically split them up so they are more independent of each other in a way. So you can see that we have these defining features. These look a lot more abstract, and these look a lot more smaller and abstract. And it doesn't even look like it's part of the same image anymore. But yeah, the idea is that we're just splitting these into different features and using that to get or understand patterns within an image, right? And once we understand those patterns, that's kind of how our model is able to interpret our image and is able to train on them and understand what class or what ID this image might be going into, right? Does anyone have any questions? Okay, so now I'm going to showcase a quick little demo, and let's see if I can put this up here. So unfortunately, the person who was supposed to do this demonstration is out sick today. So I'm going to do the best I can to explain this, right? And unfortunately, I can't run this on my environment for some reason. So I'm just going to see if I can just show you guys the outputs of these and try to explain along the way and hopefully answer any questions you guys have, all right? So first thing we do, we bring in our Python libraries. We have NumPy, Matplotlib, Pandas. These are all data science libraries that you would typically use in the machine learning context. Okay, then we bring in our deep learning libraries as well. So we have Torch or PyTorch. I don't know if you guys have heard of it, but it is basically a library that you use for developing neural networks and deep learning models in order to develop these models and also import them as well in order to train them and test them as well. So I'm pretty sure this is the most popular deep learning model that you can find. So it would be recommended to use this whenever you get into deep learning. And then you also have a few libraries that just help us get our inputs, right? Like CV2 and OS. So looking at this, so first thing we do is we define an image data set. And what this is basically doing, just at a high level, we are creating a class that represents um, an image data set, right? And this image data set, uh, you can be any just data set of images that has a label associated with it, right? So the idea is that you have a bunch of images, and then each of those images has a predefined label, and that's kind of how it's able to test on that. So you see here, we define our image data set. We are able to perform functions like get the length of it, get a specific item, split our data into training data set as well as testing data set. And then we can also grab our image data set or instantiate our image data set so we can actually use it. So, all right, so here what we're doing here is we are loading a CSV file with our class labels. So this is how we match our outputs to our inputs. We set up our data set. We create this thing called a data loader, which allows us to load our data into our neural network. And then what we do here, we just iterate our class index to the original labels. I'm not sure why this is there, but yeah, this is just preliminary stuff. And then we have exploring data. So this is just being able to look at the data before we start using it. So a lot of stuff here. So you can sort of see what the data set looks like right here. So we have our images, like I said. So this is just a bunch of traffic signs. And you can see here we have a label associated with each of these, right? So we have so this image would be the input, and this label is essentially the output that is associated with that image, right? And we have quite a few images. So now that we've shown and explored our data, next thing we want to do is create a data loader. So what this basically is doing, we are transforming our training data set or our training data and our testing data as well in order for our neural network to be able to interpret it and make sure that we don't run into any dimensional problems, right? We kind of want to make sure that our data is corresponded correctly to our PyTorch model whenever we create one. So this is what this is doing, right? Don't worry about like some of the what's actually going on. Um, you know, so it's okay if it's not understandable right now, but just understand the general idea behind this, which is just setting up our data loader to our model. Okay, so what we're doing here, we are creating our test and training data set, or we are applying those transformations to those data sets and actually getting our training and testing data. And then we define our training loader and our testing loader. So this is what we actually place within our model in order to train and test it. And the next thing we're going to do is we are going to build the model, right? So we define this thing called, like I said, convolutional neural network. This is in a class format that we will instantiate later as an object. So first thing we do, we initialize. We have an initial function, initialize function, and you can kind of see these different layers here, right? And these are actually the same layers that we talked about earlier. So you can see this conv 2D layer right here. That's basically the convolutional layer that we talked about earlier, which basically just splits our image into features and our features into more features and whatnot. And then you can also see this max pool 2D, which once again just reduces the size of our features so we can have a better computational performance. So we have just a bunch of layers here, right? And that's kind of how this convolutional neural networks really work. You just have layers on layers on layers, right? And then lastly, you have our fully connected layer, which just brings our features into a output that we can interpret. And then we usually have a forward function right here. And what this basically does is that we take in an input x, and this x value basically just goes through all those layers that we defined earlier, right? So the self.bn1, that's the same bn1 that's right here, right? We define it, and then we pass our input through these layers, right? And then as we pass our layer through these, we pass our input through these layers, we eventually flatten it, and then we return our output right here. So that's kind of how this neural network looks, right? This is basically the basic structure of what a neural network looks like in code. All right, so now we're going to actually train our model, or look how it's being trained. So first thing we do, we set our device to CUDA. So this basically defines what processor we're going to be using. Then we define our loss functions, and what this loss function does is that it basically allows our model, our model to be able to see how different our expected inputs are from our actual inputs, or our actual outputs, sorry. So this just detects how, I guess, different our outputs are from the expected data, if that makes sense. So just detects how bad our model is right now, and what our optimizer does is that it improves upon that loss value, right? So our loss function basically tells us how bad our model is doing at the moment, and our optimizer optimizes based on our loss values, right? And then you can see here we also define a model that we defined earlier, which is the CNN class. All right, so this is what a training loop usually looks like. So we just run it for 10 iterations. I don't know why it says 15. So you run it for as many iterations as you want, and you iterate through the training data. You iterate through these images as well. You can kind of see here we have our outputs, right? And once again, our training loss, or just our loss in general, is basically showing us how bad our model is, or how close our model is from being like perfect, right? So in the beginning, we have a pretty high loss because it's just getting a bunch of random values. But as we keep training our model, you can see that value kind of decrease quite a bit. And this basically shows us that our model is training correctly and that our model is actually getting better. So that's good. And then we also have our validation loss. This is just basically kind of the same thing, except we're just testing on different data. And lastly, we have evaluating our model. So this is just to see how good our model actually is. after we trained it. So this is basically made the same way as a training model or training loop. So we go through all these images and their labels, and we eventually run that, and then we get an output, right? And this is what our model is actually doing right here, right? So after we trained it, we're testing it on our test data, and we are defining a label to each of these images, right? So it's basically saying, hey, I got this input of this 40 kilometers per hour speed limit sign, and we are labeling it as correctly so, right? So it does that correctly. Then we have, speed limit here, don't go left, and all these different things. So it looks like our model is pretty good at doing what it does. Um, yeah, it looks like it's all pretty good, right? So it's able to correctly recognize these images to their respective labels that we defined earlier. All right, does anyone have any questions? I know that was a lot. All right, so I am going to conclude this presentation. Let me bring up the code. So this is the attendance code. If you want to get credit for coming to this workshop, feel free to sign in and scan the code. Yeah. You know anything about smart? So what's the problem again? You have to put in all lowercase. Okay. Yeah. I didn't have anything to do with that, so I guess put in all lowercase. Closing words. Oh yeah, it's a screen.